Hi, and welcome to TEMEKO. In the next couple of videos, we are going to learn how to form the equations of motion of a multiple degree of freedom system that consists of multiple bodies which are attached to each other by a set of springs. There are two different methods which we can use to form these equations of motion. One is based on force, which is called the Newton's method, while the other is based on energy, which is called the Lagrange's equation method. In this video, we will stick to the Newton's method and we will apply it to a dynamic system to form its equation of motion. In the next video, we will go through Lagrange's equation method. So without further ado, let's get started. The first thing is to understand why we need an equation of motion at all. Well, think about the situation where we would like to analyze the dynamics of a high-performance car. To analyze this kind of system, we would need to take into account, for instance, its mass, the stiffness, and damping properties related to its suspension, and also the driving force. So as you can see, there are multiple parameters which we need to handle. Now comes the important question: how on earth could we keep all of these parameters in check? Luckily, there is an answer to this problem. And the answer is, yes, you guessed it right, the equation of motion. The equation of motion helps us in this task by gathering all the required parameters under one equation or one system of equations. There are other scenarios where an equation of motion can be a useful tool to us. One of them is when we want to find a vibrating system's natural frequencies and modes, which describe how the system can deform. Additionally, we can also study the system's response to some applied harmonic external force which induces the system to vibrate if the system's natural frequency is close to the frequency of the excitation force. Okay, now that you are familiar with the purpose of equation of motion, let's go through the steps of forming the system of equations for a shown multiple degree of freedom system which consists of multiple bodies. Like I said, there are several methods to form this group of equations, but for now, we are only going to focus on Newton's method. In Newton's method, we first draw the free body diagrams for each body in the system. So if we would have a system that consists of three separate bodies that can only translate in the horizontal direction, each one of them introduces 1 degree of freedom into the system. So we should draw a corresponding free body diagram for each one of the bodies. After we have drawn the free body diagrams, the next step is to formulate equations for forces and moments that are acting on the bodies based on Newton's second law, which is also the core of Newton's method. Again, since we have 3 separate bodies, we also have 3 separate force and moment equations for the system. It is important to keep in mind that the positive direction for each force is the same as the direction of positive accelerations in the corresponding free body diagrams. In the final step, before we form the system of equations, we will simplify and rearrange the variables that are present in the force and moment equations according to our selected coordinates, so that the equations can be easily interpreted. For a system which has 3 degrees of freedom, we finally obtain a group of 3 coupled differential equations which are also formed in the matrix form. Notice that this group is our system of equations of motion, in which one equation for a certain body is written as m times x double dot plus k times x equals ft, where m is the mass matrix, k is the stiffness matrix, x double dot is the vector of accelerations, x is the vector of displacements related to the system's generalized coordinates, and ft is the external force vector, which includes corresponding forces that are affecting the system's bodies. And that's it. That's the whole procedure for forming the equations of motion for this kind of system. That wasn't so difficult, was it? Hopefully, after watching this video, you are now familiar with the purpose of the equation of motion and how it allows us to analyze different kinds of dynamic systems. You also now know how to form the system of equations of motion for a certain multiple degree of freedom system using Newton's method. Thanks for watching and have a nice day.